Is this visible?
Yes, sir.
Yes, sir.
Yeah. So, Sarah, because you are in class 12, don't hesitate if you have any question, if you don't understand. Okay.
Yes, yes, sir.
Okay. So let's start work, power, energy. And whenever there is a discussion about work, power, energy, we discuss about work. One of the basic thing. Jordan, what is work?
So when
Huh?
amount paid work definition, yeah, I
Yeah.
forgot. Basically, when
Okay.
force is applied and amount to displacement or any reactions is formed,
Mhm.
is called work.
Hmm. This is correct. When you apply force on any body, and this body have some displacement. Remember, displacement, not a distance. Example, if a load, a container is kept on your head, so force is acting in the downward direction, but there is no displacement as such. In this case, work done will be zero. If we are moving in a circular path, force is acting, but again, net displacement is zero. So you will say no work done. Understood? So force, which is responsible for displacement, will cause work. That's why we say work is equal to force into displacement. Anvita, is work done scalar quantity or vector quantity? Anvita,
So, vector.
work done is scalar quantity. How do we know? Because I didn't mark any arrow on the W, correct? Because it is a scalar quantity. But it is product of two vector quantity. And how to identify, guys, based on the formula? If you see dot, then it is a scalar quantity. If you see cross, then vector quantity. Like when you calculate the torque and it is P cross E, it means torque is a vector quantity, correct? Or torque is equal to R cross F. Cross means vector quantity. If you calculate force is equal to Q, V cross B means force is a vector quantity. If L is equal to M R cross V, it means L is angular momentum vector quantity. Understood? Any doubt?
No,
No,
sir.
sir.
So whenever there is a cross, it means cross product vector quantity. And whenever there is a dot, example, uh, here in work done, you write this force dot D. Other than that, where do you use the same method? When you calculate potential, when you calculate phi is equal to E dot ds. Do you remember this? Right?
Yes, sir.
So in this case, what is happening? Electric field is a vector quantity, area vector is vector, but you have dot between them. So this flux, electric flux will be scalar quantity. Understood? So this is how we can calculate. Next, if example you have a box, this is the box have some mass. So if you are applying some force, example you are pulling it with some force, and it lead to the displacement of the box and box will move to this. So there is some displacement from here to here. You will always measure from the center to center. See, basic formula you never have issue. Where you might face issue is the measurement from where you are measuring. Okay, so if this is theta, Sarah, what will be this factor? Cos theta or sin theta? This part. Is this f cos theta or sin theta?
Cos. Cos
Yes,
theta.
cos theta. So side with the angle is cos theta and opposite side will be sin theta. And if we calculate Varinder this, what will be this side?
Sin theta.
Sin theta. Okay, so we know this cos theta is responsible for the actual displacement. That's why if you calculate work done here, what will be the value? Force is actually F cos theta, which is responsible for displacement into displacement. So FD cos theta. Correct. Second rule you already know. In case of dot product, you use cos theta. In case of dot product, like A vector dot B vector is equal to AB cos theta. Pratigya, what happen in case of cross product?
It is sin theta.
Sin theta and one more thing, unit vector and unit vector. If you take A cross B vector and if you calculate, it will be AB sin theta and unit vector. Why unit vector? Unit vector tell us about the direction. In case of dot product or scalar quantity, we don't have any direction, so we don't need to mention specific. But here, because we have uh, this in the form of vector quantity, that's why unit vector tell you about the direction. Correct. Even from here, you can easily tell because this is the dot product, so it will be FD cos theta. But even practically, we can tell ki only F cos theta is responsible for displacement. F sin theta is not responsible for displacement. So F sin theta will not cause any work done. Trust me, for numerical purpose, more than cos theta, sin theta will work for you. Understood? Any doubt?
No,
No,
sir.
sir.
So whenever we see this, you will focus on 2 points. If you take force, what is the direction of force? Because specific direction is responsible for the displacement. Correct? So direction of force. And when you take displacement, always take displacement of the particular component along the force. Displacement along force. Why this is so important? Example, if you have same mass, you apply same way force F. Angle, okay, so this mass block move from A to B, then again come back to C. Okay, so what we can see, this will be the net displacement. Correct? Direction is opposite. Force is acting on this side. This will be F cos theta, but displacement will be on another side. Make sense? So, though it look easy to understand theoretically, okay, force is equal to Fd cos theta, I can remember. Yes, you can, but component of force, whether sine theta, cos theta, how it acts is really crucial for NEET. Second part is how you calculate the displacement you already know from the kind of. Understood? And because we did unit and measurement chapter recently, so what will be SI unit of work, Anvita?
Joules.
Joule. And in the Jordan, in the SI system of other unit, what will be the unit of the work?
Uh, joules or I forgot, so
The work done is equal to force into
force
displacement.
displacement,
Force is equal to mass into
mass
acceleration
into
into distance.
acceleration, displacement,
Mass is kg, acceleration is meter per second
meters
square,
second, and displacement
and is
meter,
meter. So can we say it will be also equal to kg
kg meter
meter
square
square second
in
square?
second square. Yes, sir.
Okay, that's why I ask. Ki everybody knows joule, but they will take time to figure out this. Because if you know SI unit into the basic form, then your dimension automatically become easy. So, Varinder, what is the dimension of work?
ML square T minus 2.
Correct. So, ml square t minus 2. Now you correlate with the simple basic unit. Here, your kg is the mass form, so you write m. M is the length form, so L square, and time second square. You just wrote same thing in the M, L, and T. Otherwise, everything is same with the power, same power, everything, right? Look easy. So, whatever topic we are reading, always write SI unit in this form also. Then your dimension will become easy. Next, if how to calculate work done for the variable force, because force is not always same. Work done for variable force. Just give me 1 minute. So, work done for the variable force. We know force is not always constant. It can change with the time, right? And in this situation, what should we do if anything is variable? Uh, Pratigya.
So, repeat please.
If you have variable force or your
Hmm.
displacement is different, then how to calculate any quantity whenever you have variable?
Force into मतलब displacement का initial and final वाला होगा.
Hmm.
Hmm.
Correct. So whenever you have variable thing and then you want to get the final value, remember one rule: integration. Okay, you have variable thing and you want to calculate total system, then integration. Integration means when you accumulate everything and find the final value. Make sense? Now, if you understood this, it's like if you are moving from point first to point second, P1 to P2. Okay, and if it is changing continuously, So how to calculate? At some point you will get displacement is like dr, very small displacement. Okay, and you are applying F force because displacement is changing, work will also change. So for small component of dr, how will calculate work done? Force into dot displacement, correct? Small work done. This is the value. If we want to calculate total work done, W, how to calculate? Integration, correct? And if you integrate, then same way you will integrate the other side because displacement is changing from where? P1 to, correct? And based on that, you can also see ki what is the value given. Here could be ki displacement is R1, here it is equal to R2. So same work done will be uh, same work done will be equal to from R1 to R2 force into displacement. Tell me guys, any doubt? Any doubt? Anybody have doubt in this?
No, sir.
Anvita,
No, sir.
Pratigya,
No, sir.
Oh,
Barinder,
no, sir.
Tara.
Sir, could you explain it again? Uh,
Yeah, which one?
sir, from small work done.
Yeah. So when we calculate work done for only this part where you have displacement dr,
Mm.
so there will be very small amount of work done. How to
Yes, sir.
calculate? You are applying F force on it, and
Mm.
this is responsible for displacement dr. That's why work done
Mm.
will be equal to force into displacement, force F,
Mm.
and displacement only dr. D means very
Mm.
small value.
Mm.
And integration means you accumulate everything, you add everything and get final value.
Mm.
If you
Mm.
keep on adding small work, you will get the complete work from first point to second point. Correct? From 1 to 2, if you take, you will get total
Yes,
work
sir.
done W. W is total work done. And
Okay.
in this work, you are integrating from first point to second point, P1 to P2, or in the form of the displacement, R1 to R2.
Mm.
Understood? Any doubt?
Yes, sir. No, sir.
Hmm. So, move to the next part. Whenever you do integration, remember you never get easy question in NEET directly. You will get graph in NEET. And here you will have force displacement graph. As you know, if you have force displacement graph and if you take the area of this force displacement graph, this area will give you work done. Understood, guys?
Yes, sir.
Like how PV graph will give you work done. Same force displacement graph give you work done. Right? You know, slope, whenever you calculate, then in case of slope, you get you do differentiation, right? And whenever you calculate area under the graph, you have to do integration and you get final value. Make sense? Same here, if you have graph of force and graph of displacement changing. Example, here you have R1 displacement, here you have R2 displacement. This is point P1, This is point P2. So from point P1 to P2, force is increasing, displacement is there. How to calculate work in this situation? Total area under this graph. Okay. So if you take this and this, the total area under this graph, this whole region will give you water. Make sense? Any doubt, guys? If you
No
calculate
doubts, sir.
work done here, so work done of the small from R1 to R2. Correct? Same way, force into displacement from R1 to R2, and it will be equal to the area under this P1, P2, area under P1, P2. Okay, that's all. And I have seen, I think, 2 to 3 questions in NEET from this topic directly. Okay, we'll do the basic part and then we'll solve all the PYQ from this. Any doubt, guys, from here?
No, sir.
Okay, move to the next part. Key work done, can be positive, it can be negative, it could be zero. Correct? So, Jordan, when will you have work done positive? What should be the criteria?
So worked on positives, sir.
Hmm.
When the force applied upon the body causes displacement,
Hmm.
and I don't think direction matters as long as there is displacement or a change of the body's shape.
See, one of the important thing is angle, because we know work done is equal to force into displacement and angle. So
Okay.
angle is the most important thing, right? First,
So minimum amount of force for most amount of uh, displacement.
no, that will give us yield of the work done. But
Yield.
we are
Okay, sir.
talking about this, like, is it positive or negative? So
Yes,
if
sir.
theta is less than 90, can we say there will be positive work done? Because uh, up to 90 you have positive value, because cos 90 is 0 and cos 0 is 1. So below 90 value will be positive, after that it will be negative. Make sense? And positive work done will be there when you apply external force, and this external force favor the motion. Correct? External force favor motion. Because of the external force, there is a continuous motion. Example, when body fall freely under the gravity. So gravity is acting in downward direction. Body is moving in the downward direction. So it, in this case, work done will be positive. Correct? Free fall under gravity. So gravity act downward direction. Body is also moving in the downward direction. So it is a positive one. Correct? Example, if you stretch the spring, you stretch it out, and displacement is also in the same direction. So you will take a positive work done. Right? Anvita, what will happen in case of negative work done? Anvita,
Sir, angle will be different, no?
what? What will be the answer?
I think 180.
More than 90. More than 90, it means it is the negative value you will get. So in this case, theta should be more than 90. So you will say, in first case it was acute, here it will be obtuse angle, right? More than 90 is known as obtuse angle. And in this case, what will happen? You are applying force in different direction and displacement is different direction. Like I showed you here. See, In this case, what is actually angle you can see? This. It is the angle between the force and displacement, right? So this will be the negative work done. When force and displacement are present in the direction opposite to each other or more than 90 degrees, so it will be the optics. How? Example, you can draw a diagram here. Here, if you are applying force in this direction, but displacement is happening in this direction. So angle between them is more than 90, so it will be negative work done. Okay. So in that case, direction of force is opposite to the displacement. Force oppose motion. Correct. Force oppose the motion. It will reduce. Any example, Barinder? Frictional force. Because frictional force always oppose the change or motion. Right. Same. You apply braking force. It will oppose the movement. In that case, what will happen? Force will be negative. Make sense, guys? Any doubt?
No, sir.
No, sir.
Yes. So, Tara, when you will have zero work,
So when theta is 90 degree.
yes. So, in case of zero work, theta should be 90 degree first thing because we know cos 90 value is equal to
Is
0.
zero.
Okay. So, there are three possible factors. One, if you are not applying any force zero, work done zero. If there is no displacement as such, again, work done zero. Okay. Example, uh, angle is zero. You are applying force on the wall, but wall is not moving. Displacement is zero, so work done zero. And last, theta should be 90. Right? So all three factors work in this way. Example is really important because this is how you relate with the other chapter also. Example in this case. If body is moving with the uniform velocity, so force is zero. If velocity is constant, it means velocity is not changing, force is zero. Correct? Uh, any other example, Sarah?
I don't know,
Pushing
sir.
wall, because displacement is zero in case of pushing wall, right? Uh, Pratigya, और कोई example?
No, I don't know.
Any body that have rotation motion, because displacement will be zero, correct? Let displacement is zero, so it means work done will be zero, right? Example, any rotation of anything, example satellite, if they are moving, net work done is zero. Uniform circular motion, any kind of circular motion, you will see work done is zero if displacement zero. If displacement zero, right? Complete round. Make sense? Any doubt, guys?
Yes, no, sir.
No,
No,
sir.
sir.
No,
Good,
sir.
good. So then frame of reference. You know, in physics, what is the most important thing is frame of reference from where you are measuring the thing. So, Jordan, what is your height?
I'm 5'9", 5'10", I think.
5 9.
5 9
So
5 10.
again, 5 9 5 10. Again, it depend upon the frame of reference from ground. Like if you stand on your ground, then it will be 5 9 5 10. But if you measure your height from the ocean, sea level, then your height will be more because your surface is present on some height from the sea level, right?
Yes, sir.
It depend upon the frame of reference from where you are measured. Correct? हाँ जी और ठीक था हाँ सब बढ़िया तो आप आ रही है ना हाँ अभी भी देखो इतनी जल्दी है बाथरूम की सलाह होता है हाँ जी अभी करनी पड़ी है तो हाँ guys, so frame of reference is most important thing. Remember, when we talk about force does not depend upon the frame of reference. Value of force remains same everywhere. So it does not depend upon frame of reference. I will write in short frame of reference FOR. Okay. But displacement value depend upon the frame of reference. And displacement value change when you change frame of reference. Understood? It depend on frame of reference. Make sense? So can we say if we are calculating work done by any force, it depend overall on choice of frame of reference, correct? If you change the frame of reference, your work done will change, correct? Example, if a man with suitcase is standing in the lift and he is moving up, then frame of reference is attached to the lift, correct? Right? Yes or no, guys?
Yes, sir.
It is related to the lift. So in that case, he is not moving. His bag is not moving. So work done will be zero. But if you take frame of reference from the ground, then person have some displacement. Then there will be some work done. Understood? So value change when you change frame of reference, and trust me, these kind of question are extremely important, especially in the recent time when they will ask tricky question. Understood? Uh, Also talking about the unit, we know SI unit is joule or kg meter square per second square. What is the CGS unit? Pratigya, ERG.
R
And this is equal to 1 dyne uh, because force in the CGS unit is dyne and displacement will be 1 centimeter.
10 to the power of 5 died na Newton.
1 dyne is equal to 10 raised to power 5. Right? And this is also equal to 1 gram centimeter square per second square, right? Again, like how we convert it into other form. Because they might ask you 1 ERG in the form of this or 1 joule in the form of kg meter square per second square. Correct? So if you convert 1 joule, it will be equal to Anvita, you are joining through two connection. Yeah, like your network is okay.
Yes, sir. Can you hear me?
Yeah, I can hear you, but can you see two account here
Yeah,
on the
yeah, I
screen?
can. I don't know. Whenever I rejoin, it shows two accounts. I don't know why.
Okay. So you know one dyne, if you convert into the dyne, not one dyne, 1 Newton is equal to 10 raised to power 5 dyne, right? And 1 meter is equal to 10 raised to power 2 centimeter. 1 meter is equal to 100 centimeter. And here, if you convert into the joule, you know 1 joule is equal to 1 Newton meter, correct? 1 Newton is equal to 10 raised to power 5 dyne, and 1 meter is equal to 10 raised to power 2 centimeter. So 1 joule will be equal to 10 raised to power 7 ERG. You know what is the problem? Most of students think, sir, it is too easy to understand. Yes, it is too easy, but they try to remember the number. No need to remember the number. If you remember the exact number, it will take a lot of time. Always focus on the how you can easily convert from one form to another form. Understood? And when you talk about the unit of the work done, there is two popular unit. One electron volt and 1 kilowatt hour. Okay? As you know, charge on the electron is 1.6 into 10 raised to power minus 19 coulomb. Correct? Same way, 1 electron volt will be equal to 1.6 into 10 raised to power minus 19 joule. Why? In your electrostatic chapter, you will study when you calculate the potential is the how much work done you have to do to bring the unit positive test charge, right? So in this case, if you calculate energy or work, it will be equal to charge into potential, right? So in this form we calculate. Understood, guys?
Understood.
Kilowatt
Yes.
hour in the form of power. Though we will do it again, but you know power is equal to how much work done we are doing in a given unit of time, rate of doing work. So work done is also equal to power into time. So power unit is watt, time is second. So this unit can be watt and second, and can be converted into different form. Here it is kilowatt, and this is hour. So you can convert it. 1 kilowatt is equal to 1000 watt, right? And 1 hour is equal to 3600 second. Now you can convert, correct? So it will be equal to 36 into 10 raised to power 5 joule. Don't try to memorize the number. Ki 1 kilowatt is equal to this. Just focus ki you know how to convert kilowatt into watt, how to convert hour into the second. Right? So let me ask easier question. Pratigya, does work
Yes.
done depend upon the time?
No.
It it depend upon like how you are considering. Example, in case of force or in case of acceleration, you have time because in the unit of work done you have time, right?
Yes.
But if other
Uh,
factor are constant, example, if force is constant, correct? If displacement is constant, then work is independent of time. Understood?
yes.
Yeah. And if Sarah theta is 180 degree, what will happen in this case? If between the force and displacement, ಆಮೇಲೆ ಎಲ್ಲಿ ಸ್ವಲ್ಪ yeah, plastic items. Yes, Sarah. It's okay. We understand that there is always some background noise. Yeah, ಸ್ವಲ್ಪ
Yes, sir.
ನಾನು ವಾಶ್ ಮಾಡ್ಬೇಕು. Yeah. So what is your answer if theta is 180? What is cos 180 value?
Cos 180.
Uh, cos 180 value is
Minus 1.
so work done will be maximum, but in the negative way. Okay. So Anvita, what happens if theta is equal to 0? Anvita,
So 1, right?
cos 0 value is equal to 1. So here work done will be again maximum, but this time in the positive way, right? One important thing I need to emphasize on is whenever you calculate theta here, it is always between force and displacement. Remember, extremely important. Whenever you calculate this theta, it should be always between the force and displacement. Always between the force and displacement. And trust me, everything in the work done is easy, but you should know which angle we are taking because you will be confused between the angle and you will have both the options. Tell me, till here, anybody have doubt, Jordan,
No, sir.
Sarah,
No, sir.
Pratigya,
No, sir.
Anvita,
No, sir.
Balinder?
No, sir.
So, if none of you don't have any issue, let's solve question from this topic. Let me open the PDF. Hmm, work power energy. Where is Nihal? Hey guys, solve this question, all of you. Here we have this force. I will reduce this by the act on the particle, this mass. Particle is displacement with this is displacement to this. So you have R1 and R2 value. Okay. What is the work done by the force on the particle? You have to calculate total work done in this situation. Okay. Calculate total work done. We use the same method. Work done is equal to force into displacement dr from R1 to R2. Correct? R1 to R2. Force value is fixed. Then dr, do integration, put the R1, R2 value, and you will get the answer.
Sir, 9 Joule.
9 joule.
हाँ.
Okay. Other people make it fast. Oh, Jordan, Anvita, Pratigya, not
So
Pratigya,
1 minute, sir.
yeah, make it fast.
So 9 joules.
9.
Nine.
Tara, what is your answer?
So 9 Joule.
9. Anvita and Barinder,
So can you explain once?
yeah, Barinder, Barinder, are you there?
Yes, sir.
What is your answer?
Sir, solve नहीं हो रहा.
Solve इसलिए नहीं हो रहा because what I told is not even required. Okay? Though you can use this method, but not required as such because it will be a long method. Okay. Now come to the question. Like I'll explain here. So, what was the force value? 3 I cap and plus j cap, right? What is R1 value? 2 I cap plus k. R2 value 4 I cap plus 3 j cap minus k. Am I right? Let me first check if
Yes, sir.
3. Yes. So, if this is the value, we know how to, like, we have to calculate work done here. So, how to calculate work done in this situation? You know work done is equal to force into displacement. Correct? You have force value. If you get the displacement, then job will be done. How to calculate displacement? Final minus initial, right? Final minus initial. So final value for I cap and initial value to I cap. So what will be the net value? 2 I cap. Final value here 3j. Here you don't have anything. So it will be 3j. Final value in k minus k and here plus k. So it will be minus 2k. Tell me guys, anybody have doubt in this? Final minus initial. And to make it easy, I will write R1 below. So you can use minus sign here. 2 I cap plus 0 j cap plus k cap. And you just subtract R1 from R2. Anybody have doubt in this?
No, sir.
No,
No,
sir.
sir.
No, sir.
Okay. So if you don't have doubt in this, now put value, work done. What is the force? 3 I cap plus j cap dot product of 2 I cap plus 3j cap minus 2k cap. Correct? Simply multiply them. Remember, in case of dot product, this is important concept. In case of dot product, if there is a same value, it will be 0. Correct? And if there are different value, it will be 1. Is this correct? Jordan?
Yes, sir.
No, this is wrong. In case
What?
of dot product,
Oh,
I cap
okay. Yeah.
dot I cap
I cap is equal to on.
or j
Sorry, J
cap
cap.
dot j cap and k cap dot k cap all will be equal to 1
One.
because
1.
cos 0 is equal to 1. What is the meaning of I cap into I cap? Means both value are in x direction. In this case, theta will be 0. Cos 0 value is equal to 1. Understood? But if
Yes,
you
sir.
take different value means I dot j or j dot k or k dot I. In all these situation, you have angle 90 because I means x axis, j means y axis. Both have 90-degree angle. Correct? Just give me one. Hello. नमस्ते मम्मी. हाँ बढ़िया. क्लास में बैठा था. खत्म होने लगी. हाँ. नहीं मैं तो यहाँ मैं तो क्लास खत्म होने लगी. हाँ कोई नहीं मैं करूँगा. ठीक. हाँ. 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 क्लास में जाहिर है मैं कमरा. ठीक. ठीक. So guys, in this case, if you are confused, I cap means x axis, j cap means y axis, and you know y and x have 90-degree angle between them, and cos 90 is 0. That's why this full value will be equal to 0. Any doubt?
No, sir.
Okay. So if you understand this well, what will happen? This is 3 and 2 both are I. They will be multiply. J and j will be multiply. In first case, k value is actually 0. In second case, value is this. So what will happen? 0 multiplied by anything will be 0. Any doubt? And if you understand this, 3 2 ja 6 and 1 3 ja. Anvika and Brinda, do you have any doubt?
No, sir. What?
Remember when you are doing work chapter, dot having the complete information about the dot product is extremely important. Okay, that is why even if you are confused, I am intentionally giving this value so you are not confused for the future. Okay, and to make it further easy for the calculation part, what you can do is I will make it slightly big. You can write in the more detail. Example, you can write force as 3i plus j into 0k. Correct? 0k cap dot. What was our displacement? 2i cap plus 3j cap minus 2k cap. So what is the benefit of this? Benefit is that he 3 2 ja 6, this one, 1 3 ja 3, this one, and 0 multiplied by 2 is 0. Understood? Any doubt?
No, sir.
No, sir.
Yeah. So if you have any issue in the dot product, let me know. I will explain. But remember, if you don't understand this thing, you will face issue in the work done also. Dot product. Let me know if anybody need a slight explanation on dot product. No?
No, sir.
Good.
No, sir.
Good. So then solve next question. What is constraint to move in the y-axis subjected to the force this? What is the work done by this force in moving through a distance of 10 meters along the y-axis?
Sir, option C.
Option C. Okay,
It's a 150.
150. Other people make it fast.
So 150 joules.
150. Anvita and Sarah. So when you see this question, force is given, displacement you can write is 0 I cap, and because it is in the y axis, so it will be 10 j cap and 0 k cap, because only in y axis. Correct. If you multiply 2 with 0, 0, 6k with 0k, 0, and 15 with 10, 150, right? Because work done is equal to force into displacement. Force value, displacement value, you will take dot product. So here you have only in y-axis 10j. Here 15j in y-axis. Both will be multiplied because you have work done only in y-axis. So 15 multiplied by 10. Okay. And if I have to do in the NEET exam, how will I do? I will just check. 15 is given, 10 is given, 150 my answer. Done. Any doubt, guys? Was it really easy question?
Yes, sir.
If it was, then solve next question. You can use this formula. You know, kinetic energy is equal to half mv square. Correct? So work done
Answer
is equal
B.
to difference in the final kinetic energy and initial kinetic energy. Final is half m v final square minus half m v initial square. So half and m is common. So v final square minus v initial square. Yes, Atika, what was your answer?
B.
B.
Yes, sir. B.
B.
So I'm getting B also.
Okay. In two more class, we'll finish this easily. Yeah. So, what is the mass value? 10 gram. If you convert into the kg, then it will be 10 gram divided by 1000 in kg. Velocity you have already worked on is equal to 1 by 2. Mass is 1 by 100. What is final velocity? 500. 500 square, 25 and 40. Correct? Minus 1000 square, 10 raised to power 6. Correct? So what will be the value? This is 2.5 lakh, no? This is 10 lakh. So 7.5 lakh. Correct? 20 cancel. You will get the answer. Any doubt, guys?
No,
Anybody
sir.
have doubt in this? Just put this formula. Ki work done is equal to, and we are going to use a lot in work energy theorem. We will use the same equation. But I have seen some question from this topic. See, you have this in 2019 variable force, kinetic energy, simple question. Work energy theorem in variable force. We're gonna use any other topic, power, collision. Oh wow. Collision is the most important part here, guys. Extremely important. So we will take time on the collision, do this question. This is the last question for this session. Simple integration, right? Correct. So do integration.
25.
Yes, Pratigya.
25.
20, 25. Everybody got answer? Everybody got answer, or should I explain this? Brinder.
So the answer is 25 joules, no?
Yeah. Brinder, you got it?
No, sir.
Okay. Anita?
So can you explain?
Yeah. Sarah?
No, sir.
Okay. So in this question, when you are solving, you have to focus on the integration part, how to do integration. Okay. First, in the short, I'll tell how to do integration. Though you already know it, still. Whenever you do integration, you do in reference of something. Example, you do integration of x with respect to only dx, nothing else. Okay, you do integration of x only with respect to dx, nothing else. If you have power n, then integration will be x n plus 1 divided by n plus 1, right? This is the rule. Example, if you have x raised to power 0 with respect to dx, then what will be the answer? X 0 plus 1, 0 plus 1. So 0 plus 1 is 1. Here it is 1. And denominator, it will be 1. So no need to write. So can you say, if anything have power 0, it will become 1. If you have power 1 already, use same formula. X n plus 1 divided by n plus 1. Can we say it will be x square by 2? Any doubt, guys?
No, sir.
No, sir.
Huh. So, if you understand this really well, now we can solve this question. So, what was the force value? 20 plus 10y, right? And your R1 value is 0, R2 value is 1 meter. You have to calculate work done. So, how to do? Work done is equal to integration of dW or integration of force into displacement. In this case, we are taking dy, displacement in the y form. From R1 0 to 1. Force value is 20 plus 10y with reference to dy 0 to 1. What is the integration of 20? If you do integration of 20 with respect to dy, I told you this formula. If you don't have any power, it will become 1 power. So it will be 20y. If you take 10y with reference to dy, so it will be 10y square by 2 or 5y square. Yes or no, guys? Any doubt?
No,
Tara,
sir.
Anvita, Binder, Jordan. So
No, sir.
if you don't have any doubt, for 20, it will be 20y. For 10y, it will be 5y square from 0 to 1. If you put one value at the place of y, 20 ones are 20. If you place at the place of y square, 5 ones are 5. Tell me, anybody who is not sure like how we got the answer, let me know. I'll explain this again. Anybody have question?
No, sir.
No, sir.
Anvita,
No, sir.
Sarah,
No, sir. No, sir.
प्रतिज्ञा तुमसे नहीं पूछेंगे हम, ठीक है? So,
You, sir.
as a discrimination, we love to do discrimination in class. That's the reason. Okay, so whatever question you have, go through it. If you don't have, let me know. I will send you question from this topic. Solve it. At 12 o'clock, you will have class again. Take break and we'll do chemistry. Redox, some topics were left out, so we'll finish the redox part. Okay, so yeah, that's all. And I will also share PDF today from the unit and measurement, all 50 explanation. Go through it. If you have doubt, let me know. Understood?
चलो संडे का आंसर की
संडे का आंसर की मैंने नहीं भेजा,
No, sir.
तो I'll send today by 3 o'clock. I'll send. Okay.
ओके सर